All right, welcome guys. This is the seventh PCB design workshop. Let's get started. Okay, so we have our schematic that we were working on in the last video. The first thing I want you guys to check. Oh, you know what? There were two concerns. The CP2102 here, some students weren't able to find, and that's because I had a imported version. So you can use, I believe this is the one I imported. So as long as you use this QFN28 CP2102NA XXX, and the X are like free cards, those could be any number, any letter, whatever. It will work for that device. So this is the one you will use, and then just make sure you have the same connections, which it looks identical. Yep. And then reset instead of reset B. Some of the names are a little different, but yeah, for the most part, it's exactly the same. So just use that chip. And then for the switches, you can use any switch that represents a switch. The only thing about these ones is that their footprint is specifically a BS3. That's not a BS3. Maybe I don't have it. I guess I don't have it. It doesn't matter because we're going to change this footprint later on anyway when we get to the layout. So you don't have to worry about this. Just pick any circuit that has a two-terminal, single pole, single throw switch. So if you guys haven't done it already, go ahead and click this button right here, fill in schematic symbol reference designators, and then annotate everything. And so that'll fill in the numbers on all your components, R1, D1, C1, U1, so on. And then the other thing is we'll have to pick all those footprints. So I guess we'll get this out of the way now. Let's see. So all of your capacitors, it looks like every single one of them are going to be surface mount 0201 0603 metric. So you can go ahead and find that. That is in capacitor SMD, and then it's the very first one, smallest capacitor. Okay. You will click right here. Kind of looks like an Excel sheet. So all the capacitors are 0603, 0201, and then 0603 metric. Let me know once you have all those. You can also, once you place one, you can copy and paste them in all the other footprint areas. What's up? I'm sorry? Everything is useful. I see. That's an issue. So those labels aren't the same labels. Those labels are for actual physical connections. You can't use that to name the little text boxes. So you make the text boxes by this one. You can either click on the T or you can just click T in your keyboard and this will pop up. You can type in what you want. Okay. And you can see it has a blue tint to it rather than this one, it has a black tint. You'll also see when I disconnect it, it has this little square. That square is meant to be connected with something. Okay, so I had it connected to here because that's going to be the USB connection. And then that's going to get regulated and then give 3.3 volts to the rest of the board. So make sure you look over all those. And then, so there's only 3 connectors. So just double check your USB connector and your 2 1x19 male connectors. And then try and annotate again and see what you end up with. I'm gonna do something really quick. I'm gonna switch the buttons too, so you guys can go ahead and do this. Yeah, SW _push instead of these confusing BS3 ones. Is that what you used? Or okay, yeah. All right. In whatever way looks more like nicer to you, you can feel free to organize it that way. The only reason, so I'm picking this different switch and then I'm gonna go find this footprint because I'm using that in my senior design, so I know for sure that this is a proper available component. Um, it'll just make our lives easier. Let's find the switches.
Yeah.
You need help? Or is everything
I
okay?
hope so. Now we just doing the libraries. He wants to do all of them, right?
Yep. So after the capacitors,
What can you focus?
hold on, let me the drop down. You can do the switch too. So I found proper switches here. You want to try and maybe like we have a special microwave oven for doing surface mount components, and we would just need the paste, the solder paste.
Yeah.
You guys want to try and do it like in-house, a dev kit, and then we can hand solder the male pins. Yeah. Yeah, it might be interesting. All right. We can mess around with it if you guys want. It is pretty small though, yeah. It's about this big. Some of those components, like, yeah. I'm curious how the manufacturers do it. Like how they spread the paste out on the board. I'm not exactly sure how they do it. Huh? Hmm. Stencils that just helps you solder it though, I thought, right? So like everywhere where the stencil's cut out, that's where the paste goes. Okay. Okay, because we can actually order stencils as well with our boards. Yeah, just some cheap metal, probably aluminum or something. Yeah, but some of our components are smaller than like a needle. So, because this is the actual like mainstream developer kit being sold. So, with one slight adjustment based on some online user feedback. There's a couple of forums about it, but some people are having issues with the auto program functionality. So I added the capacitor between the enable and the ground to help fix that. Hopefully. Yeah. I I had one technician guy. He was a really older dude, and he like knew so much about like working with HVAC. But he was like, "Man, I've always wondered why there's all these resistors on these boards." I'm like, "Let me tell you, I got some information for you." Hmm? Hmm. Yeah, one of my best friends does HVAC too. Works in the union. Don't mistake these. The shop key is SOD 323, but the TBSs are SOD 523. Okay, so those are different sizes. Just, yep. I'm gonna add some extra text to this value for the transistors. We're gonna pick the exact transistors that the real dev kits use, which are J3Y transistors. You guys don't have to include that, but I'm gonna include that, and I'll show you guys why I'm doing that later, when we get to the bill of materials, because we're gonna do a BOM for this one, and I'll show you guys the ordering process, and then hopefully by then I will have approved funds so I can order everything. But that all depends how long. What?
Well, if we don't get this one.
Well, we have the funds, we allocated it and I'm waiting for approval now. That's for the name tags. And so I have to do another order for the dev kits, which will probably come in November sometime, depending on also how long they take to ship. There's also some political stuff going on in the background that might also cause issues from ordering through China. So I don't know. I don't know how that's gonna go. I'm not gonna go into details about that. You can look online. It might be fake news too, so who knows?
White?
Um,
Yeah.
for this one,
The name.
so it's gonna be pin header 1x19 with a 2.54 millimeter pitch vertical. I don't understand. Oh, I see. Okay. Yeah, vertical. Hmm. Huh. Mm-hmm. J2, J3, and so J1, that connector is a USB, but the for me 2 and 3 are the 1x19 male connectors, which are going to be the pin headers. I'll show you guys what the board will look like in the 3D model after this. Did you guys find the USB too?
Yeah.
Yeah, okay. Yep. For these transistors, the package type is SOT-23. That looks something like this. They're very small. So that's a NPN transistor. Or is it a PNP? They are PNP. No, it's flipped. NPN. Wait, is it the arrow going into the not pointing in? Okay, yeah, they are NPN transistors. NPN not pointing in, the arrow is pointing out of the away from the transistor, so it's an NPN. If the arrow is pointing in into the transistor, it's a PNP. Cool tip for you guys online. Not pointing in, man. He'd be upset.
Come back to transistor.
Depends what classes you take. If you go into power electronics, you'll learn about SCRs, which are technically more semiconductors. IG. What's up? I enjoyed the class, but it was really hard. And that's something I wanted to tell you about telecommunications is out of anything in electrical engineering, it's the most mathematically demanding part of our whole degree. So it's going to be the hardest part of everything. So just be prepared for a challenge. It's going to be tough. Communications. I personally believe communications is the hardest part of all of engineering because it's the hardest thing to visualize and mathematically it's very intense. And it's very physics intense too. And well yeah, because of electromagnetic waves. You don't like physics? I love physics. In fact, if I wasn't an engineer, I'd be a physicist.
I say, I was gonna get my associate.
Mhm. Oh wow. I was trying the minor in physics, but quantum and nuclear and stuff was only offered every other year. So yeah.
Wow.
So I decided not to do it because I couldn't fit it in my schedule. What's up? You're doing computer and electrical? Nice. Yeah. Yeah, I know. Yep. Even your senior design, like you don't have to do two, they count for both degrees.
I just talked to him lowly on Friday. He said I can do it. I'm gonna have to talk to him again. And he got like, "When was this?" I was just today. I started.
Mhm.
Well, the last.
Yeah.
Grandfather.
Right, right. What has changed for you?
The main
Just curious.
thing is elective. On all of their new agreements, it's advising lines. So for the most part, it's got order. We need more upper level electives, like the high 3,000, 4,000.
What
I think a lot of 2,000.
what electives did you take?
I have to take it.
Oh, okay.
I would take it on the test. Yeah, but I'm not like.
Okay. Right, right. I was just curious because I'm in data structures and software design right now. Software design isn't anything that I thought it would be.
Oh, yes.
So software design has nothing to do with programming. It's the bridge in between when you have a customer and you need to make a software for that customer. Software design helps going through that process of making that software, making sure that it does everything the user or customer wants, laying out all the classes and what they're going to be used for, what the attributes are of those classes, what are their operations. We learned the object-oriented way for software design. I'm sure there's other methods as well. But that's basically the gist. That's software design. That's my take on it, at least.
How do you like that?
You make an app by the end of the class, so that's cool. Yeah. So I'm doing through the Android developer kit because I didn't want to learn Swift. He finished it. Yeah. What is software design? Oh, Swift. Yeah. I don't know. I have no idea what the syntax looks like. I have no context. Yeah,
Yeah.
yeah. Well, and you gotta think about it. I mean, I may use an Android, but what is the main public using? If it's iPhone, it's more marketable for me to make it. But I'm pretty sure Microsoft is still leading on Windows. Hmm. Yeah. Yeah. That's funny. Yeah. Um, for the push button, this one might be a little hard to find. So it's a button switch surface mount device, switch push single pole single throw. I don't know what NO is, but it's the Alps version. That's the one we're gonna use. And then this linear regulator is also SOT 223. All right, cool. That's why it can matter what components you pick. Some of them already have footprints associated with them, saves you some work. But, what about the CP2102? Does it have that as well?
Yeah.
Yeah, okay. All right. And then yeah, so you can use either one. So here's so let's compare. Let's compare. So I'd actually, looking back and comparing,
Okay.
I'd probably use this one because it has the keep out zone created for you and it has some extra notes and stuff and it tells you, hey, this is the antenna. That might be a better one actually. Okay. All right, save schematic and continue. So are you guys done with the schematic portion?
Yeah.
And you guys have no errors or anything? Yeah, you go ahead and run the ERC. Yeah. I just got this one, which isn't an issue, but it's the one that looks like a checklist here with the check mark. That's not good. What kind of errors you got? This will help you get used to the process. So if it's just the one, that's okay. You can ignore that one.
And not connected.
Oh, yeah. Oh, your signals. And then you gotta type your name.
Just exit out.
Oh, no. Okay. So you did, yeah, you did all the text. So text is just for like notes, like comments. Well, you can physical connection.
Okay.
And that one you can ignore. Yep.
That makes sense now.
Yeah. For those of you that are done with the schematic, go ahead and save and then you can go back to the main library here and you can start create your PCB new. I named it ESP32 dev underscore kit. And once you made that, just go ahead and open it up and we're gonna start messing around with this. I'm gonna go ahead and fix some stuff really quick. All the components, right? Yeah, so that is why we call it a rat's nest, okay? That because it's gonna look really ugly once you import all your components. So the best you can do is just start organizing everything. The first thing I would do, I guess, place your components out to the side and go ahead and just start making your edge cut. So we're gonna make the layout of the board. Let's do it on front. Well, let's do it. There it is, edge cuts. I don't know why I couldn't find that. Go ahead and click on the draw a rectangle. Um, actually, would anybody happen to know off the top of their head the pitch between the pins on a breadboard? Can one of you guys Google it real quick? I'm gonna take this moment to fix the board so it's symmetrical when you put it on the breadboards. So
That's 2.54 million.
sorry, I'm gonna do something really quick. 0.1, okay.
So it's 2.54 million.
And then what is the distance between the center of the board where the two sides are, like where you usually put the IC?
Yeah.
Is it 0.3? So we need so it has to bridge the gap, that's 0.3. And then 0.5, 0.7, 0.9. So we need more like 1.5, right? Oh man, that's really hard. There we go. You know what? I'll just at this. I'll just remake the whole thing. I'm sorry. So we're gonna go the edge cuts. We'll go to the edge cut layer. Are you guys all in the layout?
We're just waiting for you to sign it.
All right, cool. So we're gonna go to edge cut, which is right here. I'm going to change my grid size to make my life easier. 0.1 inches should be good. And then we're gonna do a rectangle. And we're gonna want, I think 1.5 inches would be good. 2.3 should be okay. Let's compare, see how that looks. Yeah, that should be fine. Yep, so then just go ahead and, so I'm gonna delete these edge cuts. We'll do the curves in the corners later. I'm gonna, and then if you guys need like a more fine movement, go ahead and change your grid again. So I think this should be good. Mm. Oh, one more thing. I can't believe I forgot this. Go to the um board setup. This button right here, top left. You need to go to physical stack up. And this is going to be a 4-layer board, okay? Then I believe everything else should be defaults, so that should all be okay. No constraints. So yeah, just do the board stack up and then click OK. So this, if I didn't mention it already, this is going to be a 4-layer board, so it's going to be a little bit different. And then just, yeah, start organizing components. Pay attention to your the lettering here. So D2, D5, D1. Make sure it's exact. Everything red is on the front copper. Everything blue is on the complete back side of the board. And then the only thing that's going to be in the inner 2 layers are going to be through hole connections. So this is one of the reasons when we do our ground plane on the board, this footprint came with a keep out zone. So one of the other zones you can make aside from like ground planes or ground zones or power zones, you can make these keep out zones and it won't let any copper go into this keep out zone. And that's just because we have an antenna here, so we don't want any like high voltages or high frequency signals going through that. You know, that will add a lot of interference. What are you trying to import stuff into your library? You can add footprints. So I don't know why it's not letting. Like I can go to this ESP32, I can go to edit footprint and yeah, you can do that too. There are some huh. Yeah, see, look at that. I just moved the earth pad on the ESP32. So yeah, I don't know why it won't let you. I don't know. Sure, hold on. Oh, you guys might have different numbers, right? Okay. I see. See this here. Okay. Here's my numbering for everything. You can take pictures of this. So you took a picture of the top and then, well, you know where all the U chips are because those are the obvious ones. Um, and then with that, I'll zoom in here and you guys can take a picture of this as well. Let me hold on. Let me make it easier for you to see the stuff. Yeah.
How do you do that?
On the left here, here's the rat nest lines. You can click it and you can also make them curved if you want. If that helps you a little bit, you can curve the rat nest lines while you're making connections. Right, yeah. Did you try turning it on? Are you guys able, can you guys get a clear picture with this? They don't have to be lined up perfect, but so there's that. And then here's the back side. So you can take a picture of that too. Wait, 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 wait. There you go. That's better. The yellow is the front silk screen, the pink is the back silk screen. Sure. Not bad. Yeah, yeah, hold on. I don't know what that noise is, but that's been happening all day. Yeah. Something heating or HVAC. Right? Yeah. Okay. So that's the layout for everything. It doesn't have to be like exactly lined up and everything, but you're gonna want to give these components a bit of space. I might even move these male pin connectors a little bit over. Um, but there's gonna be a lot of traces, so that will be the hardest part of this board. Unfortunately, all of these silk screens, you will have to manually add those in yourself. Um, the way you do that, if you don't remember, is you go to your layer here, you go to front silk screen, because we want it on the front of the board where you can see the pins. And then we might want to put it on the back side too, actually. That might help some people. Well, no, because it's gonna go on a breadboard, so it won't matter. So you can just do the front side and then you just click on text and you'll type in each one 3.3 volts and you click OK and then you can place it wherever you want. I have mine in the top left here. Um, these have to be exact though. So this top left has to be 3.3 volts. This second one has to be enable and so on because that's how we have it connected in the schematic on the male pin connectors. Are you trying to filter it or are you trying to, what are you trying to do with that? Go ahead. I mean, I would say just make sure whatever capacitor you pick's rated for 5 volts. You shouldn't have an issue, but try and use ceramic as well. Ceramic capacitors are less noisy compared to electrolytic capacitors. On the board here, right here. So R6 is 22.1 with a 5% tolerance, and R7 is at 47.5K, also with a 5% tolerance. Sure. It's 10K, 5% tolerance. R2 and R3. Nice.
I'm assuming your art's in the
This one?
very first command. Yeah.
Right here.
Why?
So they're numbered differently?
Well, they have the same values, but they don't group them together. Only 2 and 3 are put together. And,
Yeah, I noticed that too, like some of these are not grouped in the same place. Double check your footprints, because the only reason it would separate it is because the value isn't typed exactly the same, like if you have a space or something, or if the footprint is different. That's the only reason it would separate it in that table. Did you have like a space or something? Okay. Yeah, they're trying to implement Python scripts too, so that you can literally write up some Python code to make a circuit board. It is really awesome, but it is very, very, very beta. Uh, I wasn't keeping up with it to begin with. I was just kind of facilitating the event for people to come and learn. It wasn't as popular as the PCB design, so I think because we didn't have like a geared project to work towards or something to gain out of it. Maybe next time I'll do that gaming workshop, but I didn't have any curriculum made, so that's why I didn't run it myself. And I also have limited time, so this was already a lot for me. So if anybody else is interested in Python though, I would love to take you guys in onto the IEEE Python workshop project.
Are you still in that platform?
Yeah, I'm still in it. I'm still collecting the material and stuff because I want to learn Python in some way. Mhm.
I just did that.
Okay. I might there's a couple of cool projects at the end of that book, and I might give like a quick class on Python, maybe.
Yeah, I wonder what the volume will be of the Python.
Yeah, I don't know. I know you're implementing something, but I don't know like the scale of it. But as far as the book goes, it goes over making APIs, using math functions, and making a video game. That's what I did. Is I made a little mini uh video game. I can show it to you guys after the workshop if you want. I thank God I'm recording. Thought I forgot for a minute.
Actually made a lot of games. Thinking those, they were all very same.
Yeah, yeah. Mine was a knockoff of the aliens that are moving left and right and they come down.
Oh, Space Invaders.
Space Invaders, yeah. But I made it Star Wars themed. So all the bitmaps were Star Wars. Definitely a copyright, but
I had a friend.
Mhm.
Players.
Mhm. Mhm. That's cool. And then make it lasers.
Well, what I did was I made one of them shoot. Yeah, they do. They do. Slower shot.
That's cool. Yeah.
C1, C8 location.
On the layout?
No, 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 right. The number and the capacity of.
I didn't I didn't think about that when I redid it. When I redid all the numbers.
Yeah, mine.
Yeah.
It's still out the whole day. I still.
I, Because I don't know, I think it depends on the position of all the components, but you can go to the schematic reference here and you can clear all your annotations and then re-annotate. But I don't know if it'll annotate in the same order that we have, you know. And then you guys can also look out there. Here, this shows you all the values and the reference numbers here. So as long as you match up the values with the reference numbers here, you should be fine.
Yeah, but can't fill unless you know the location.
But they're the same value. So as long as the values match up, it's okay if like like C5, C6, C9, and C10 can all be interchanged because they're all the same value rating. So they'll have similar connections. Is that right? C5, C6. Yeah, right. So I could call this C9. Yeah, that should be fine because don't worry about the location too much, okay? Just get it laid out and it doesn't have to be exact. And the reason it's not important is because we're gonna use an auto router anyway to do it for us. So yeah, this time goes by so fast. So here's what the whole layout should look like by the end here. The only thing you might not have is I added a ground zone plane. Just make it the size of the board, and then we'll make adjustments to that. In the next workshop, we'll add the curve edges, and then we'll actually start routing this thing. We'll auto route everything, and I'll show you guys how to use the auto router, okay? If you don't remember how to add zones, it's this button right here. You click add a filled zone or Control-Shift-Z. And then you basically click anywhere on the board. Looks like it has to be on the board. This is not what I want. Okay, well, when you have a blank zone, it'll come up with this and it'll have the copper layers. You want the back copper and it's going to be on the ground net. And then you'll click OK, and then it'll have you start placing all the four corners. You go all the way around and then you place it again where you started, and it'll create the zone. And then it'll have the hatch lines, but it'll be empty. So you click B, and B refills all the layers because I can put a trace. So like I can create a trace here, right? And then when I refill, it'll take it out of the ground plane. I don't want that though, so
Yeah.
but I was just showing you guys. So we'll leave off here. We're gonna curve the edges just like the actual developer kit. We might drill in the holes too, but haven't decided yet. Why is this? Go ahead and just mess with the size of this. It doesn't really matter as long as you have the whole board. I just want it all to be straight. Then refill. Okay. And I'll end it here. So next week we'll auto route. Then the week after that we'll create the BOM. I'll walk you guys through the ordering process, and that'll be the end of the workshop. All right, cool. For you guys online, thank you for watching this video. I hope this has been really beneficial to you guys, and I look forward to seeing you guys next week. So have a great week.